Alright, this video is going to go over the 3 multiple choice questions from our Word Problems Day 3 packet. So the first question, they give us the position function and then they ask us about the velocity function. So typically we're going to say, alright, well velocity v of t should equal the derivative of the position function, which is certainly what we'll do here. And then where people make a mistake in this one is they say, okay, when it's at the origin, so that means I'm going to plug in 0 here. But no, the particle moves along the x-axis so that at time t greater than or equal to 0, its position is given by this. So your input is not position. Your input is time. So when you're at the origin, that's your position. So this being at the origin, that's saying that x of t is 0. And then I need to figure out what is the time at which that happens. And then once I know that time, now I can plug that, not a 7 but a question mark, now I can plug that in to the derivative, which is of course the velocity. And this is a calculator allowed question, but it's not really that terrible to solve this one here. Cosine is 0. The first time that cosine is 0 is at pi over 2. And so then I just need to square that. Actually, let me call it pi squared over 4. And then that's what I'm going to plug in here, or into the velocity. Certainly you could take that derivative by hand using a little bit of chain rule, but because it is a calculator allowed question and you can see that your answers are mostly decimals here, that might turn into something a little bit ugly. So I would just take that derivative on my calculator at pi squared over 4 and get C, I believe, is the answer once you do that. All right, number 4, in this case, they've given us the position function, or at least they've told us. They didn't actually give us the equation, but they said that S is the position. And then they want to know about the total distance traveled. And when I look at my answer choices here, I can see that they're all involving S prime, an integral of S prime. And that makes sense because just like up above, S prime of t is equal to the velocity. And we know that for total distance traveled, we use the integral of velocity. We always have to be careful with total distance traveled versus displacement. I know that if I just do the integral from 0 to 5 of S prime of t, that's going to be displacement. And that's not what I want. So there's 2 different ways that we handle this. One is to figure out where is S positive and where is it negative. And if S is, or sorry, not S, but S prime, where is S prime positive or negative, and figure out where it changes. And so we can kind of see that happening with several of these, where they're splitting it up from 0 to 2 and then from 2 to 5, because we know that S is increasing, meaning velocity is positive from 0 to 2, and then decreasing after that. So 2 is sort of where we cross the x-axis for our velocity graph, if I were to do a quick sketch here. We're increasing, and then we switch to decreasing. Let's put our 2 here. So velocity is above the x-axis and then below the x-axis. This is v of t, or S prime of t. So I could say, all right, well, it's the integral, and I haven't really looked at the multiple choices yet, and that's okay. I'm kind of taking a broader review here. It's just the regular integral from 0 to 2 of s prime of t plus the absolute value of the integral from 2 to 5 of s prime of t dt. Absolute value. Oops. Because this part is already positive, no problem, no difference between distance traveled and displacement here. But if I don't put the absolute value around this part, it's going to be negative, and this negative distance traveled is going to cancel out some of that positive distance traveled, and we don't want that. We just want the total distance traveled. So I could do it as I've written here. I look at my multiple choices. I don't see exactly that. So I do know, all that this absolute value is going to do here is just change the sign, because I know that this will be negative. It's below the x-axis, so it's going to be negative. So I see they're doing some subtracting here, so I could get rid of my absolute value and change it to a subtraction problem. That would work. They almost have that, but it switched. Right, they have the wrong one turned negative, so that's out. Now they do have, and this one again is switched. A has what I have, but they've got this extra initial position here. But they're not asking for the position, they're just asking for the distance traveled, so I don't need to include anything about the initial position. And now it's just a matter of these two absolute value ones. D is simply going to take your displacement and make it positive. Well, that's not what I want. E, when you put the absolute value inside, that's going to change your velocity graph. It's going to take the part that is negative, say, nope, you're not allowed to be negative anymore, and just flip it up here. Now the entire area underneath the curve will be positive, giving me my total distance traveled. So it is that one. All right. Number 5, here's the velocity. What is the position of the particle at time t equals 3? Well, again, if I'm given velocity, I'm going to somehow take an integral to figure out my position. Now, in this case, I don't want total distance traveled. I want displacement, because I want to know how far am I from where I started. And then if I add to that my initial position, which was -2, I should get my final position. Now my interval here is from 0 to 3. This is what my position at time t equals 0 plus my change in position from 0 to 3 should give me my final position. And I believe our answer there is A. So that's our 3 multiple choice questions for this assignment.